Imagine a time before time existed, a point of unimaginable density and heat. This was the singularity that birthed our universe. Then, in a cataclysmic explosion, the Big Bang occurred. Space itself expanded rapidly, cooling as it went. From this primordial soup, the first elements emerged. Hydrogen, the simplest and lightest element, dominated the early universe. Helium, with its 2 protons and 2 neutrons, soon followed. These 2 elements, forged in the crucible of the Big Bang, would become the raw ingredients for everything that followed. The universe, once a sea of energy, began to take on structure. Gravity, the architect of the cosmos, drew these early atoms together. Vast clouds of hydrogen and helium coalesced, their immense gravity pulling them tighter and tighter. These were the seeds of the first stars. Deep within these collapsing clouds, pressure and temperature soared. At the heart of these nascent stars, a new chapter in the universe's story began: nuclear fusion. Hydrogen atoms, forced together by unimaginable gravity, fused to form helium. This process, the engine of stars, released tremendous energy, flooding the universe with light and heat. But stars are not static entities. As they age, their internal furnaces change. The helium produced by hydrogen fusion begins to fuse as well, creating even heavier elements: carbon, oxygen, nitrogen. These elements, essential for life as we know it, were born in the fiery hearts of stars. Massive stars, their lives a whirlwind of nuclear reactions, have a spectacular end in store. When their fuel is spent, they collapse under their own gravity, triggering a supernova. These cosmic explosions are among the most powerful events in the universe, briefly outshining entire galaxies. But supernovae are not just destructive forces. They are also cosmic recyclers. The intense energy of a supernova forges even heavier elements such as gold, silver, and uranium. These elements, along with the star's earlier creations, are blasted out into space. The space between stars, once thought to be empty, is actually teeming with activity. Vast clouds of gas and dust, enriched by the remnants of dead and dying stars, drift through the cosmos. These molecular clouds are more than just stellar graveyards. They are the nurseries of future generations of stars and planets. Within these clouds, shielded from the harsh radiation of open space, atoms encounter one another. They collide and bond, forming molecules. Simple molecules like water and carbon dioxide form alongside more complex organic molecules, the building blocks of life itself. Section 5, A New World: Earth's Formation and the Inheritance of Life's Building Blocks. About 4.5 billion years ago, in a quiet corner of the Milky Way galaxy, a new star ignited, our Sun. Around this newborn star, a swirling disk of gas and dust coalesced. Over millions of years, gravity pulled this material together, forming planets, including our own Earth. The Earth inherited a rich inventory from the molecular cloud that birthed it. Water, carbon, nitrogen, and all the other elements essential for life were present. But the journey from these raw ingredients to the complex molecules of life was still ahead. Section 6. The Spark of Genesis. From molecules to the first life forms. The early Earth was a harsh and unforgiving place. Volcanoes erupted, spewing molten rock and gases into the atmosphere. The oceans were hot and acidic. Yet within this chaotic environment, life emerged. The precise details of how life arose from non-living matter remain a mystery, but we know it involved a complex interplay of chemistry, geology, and time. Organic molecules delivered to Earth by comets and meteorites and formed in its early oceans, interacted with each other. Over countless generations, these interactions gave rise to more complex molecules, eventually leading to the formation of self-replicating molecules, the precursors to DNA and RNA. Section 7. The Cosmic Connection: Life's Ingredients Across the Universe. The story of life's emergence on Earth is not unique. The elements and molecules that make up our planet and everything on it are not special. They are found throughout the universe. The processes that led to the formation of our solar system and the emergence of life are not unique to Earth. They have likely occurred countless times across the cosmos. This realization has profound implications. It suggests that we are not alone in the universe. If the conditions were right for life to arise on Earth, then they could be right elsewhere as well. Section 8. The Search for Life Beyond Earth. Are we alone? The search for extraterrestrial life is one of the most compelling scientific endeavors of our time. Scientists are using telescopes to search for planets orbiting other stars, looking for signs of water, oxygen, and other molecules that could indicate the presence of life. We have discovered thousands of exoplanets. some of which are located in the habitable zones of their stars, where temperatures are just right for liquid water to exist on their surfaces. While we have not yet found definitive evidence of life beyond Earth, the search is ongoing. Section 9. Conclusion: a universe of possibilities. The story of life's building blocks is a story of cosmic connections. It is a story that begins with the Big Bang and continues to this day in the hearts of stars and the depths of interstellar clouds. It is a story that reminds us that we are a part of something much larger than ourselves, connected to the universe through the very atoms in our bodies. The universe is vast and full of wonder. As we continue to explore the cosmos, we may find that life, in some form, is not an anomaly but a natural consequence of the laws of physics and the abundance of life's building blocks scattered throughout the universe. The possibility of discovering life beyond Earth is a tantalizing prospect, one that drives our curiosity and fuels our imagination. The universe is waiting to be explored, and the discoveries we make may change our understanding of our place in the cosmos.